In this video, we're going to talk about another type of isomers that are specific to double bonds, and this is cis and trans isomerism. We're going to be able to recognize the difference and also talk about how to include it in your names. So cis and trans happens because our double bonds do not rotate. So if we think about double bonds and its structure, we've got groups that come off in these directions. This double bond doesn't rotate, so what is on top stays on top, and what's on bottom stays on bottom. There's no way for it to just naturally rotate and switch those groups up. So I'd put D on top and B on bottom. So that is not possible. So we are going to be able to tell within a name and a structure that A and B are on the same side, or A and B are on opposite sides. Triple bonds also don't rotate, but they don't have cis and trans. We'll talk about that more with triple bonds in the next week's module. So cis and trans are going to happen only when the carbons of your double bond have two different groups attached to it. So if we look at this first example, I'm going to look at the carbon on the left of the double bond. It has a CH3 group and a hydrogen, so those are different from each other. Carbon on the right, CH3 group and a hydrogen, those are different from each other. So this will be cis or trans. In this case, the CH3 groups are on the same side, so that is cis. If I look at this other example, first group has a hydrogen and a methyl, so those are different. Second carbon has a methyl and a hydrogen, those are different. In this case, the methyl groups are on opposite sides, so it is trans. Let's look at a couple more examples. So again, it's helpful to put a line through the double bond so you can kind of see what's above it and what's below it. If I look at the carbon on the left, it has an ethyl group and a hydrogen, so those are different. On the right, we have a hydrogen and a chlorine. Those are different, so we will have either cis or trans. In this case, the ethyl group and the chlorine are on opposite sides. If I wanted to look at the hydrogens, they're also on opposite sides, so this is trans. If I look at the second example, the carbon on the left of the double bond has a methyl and a hydrogen, so those are different. Carbon on the right has two hydrogens. Those are the same, so that means this is neither. So if I look, these two hydrogens are on opposite sides, which we would call trans, and then these two carbons are on the same side, which we would call cis, so really it comes down to being neither. This last example, we have an ethyl group and a chlorine on the same side, so those are different. On the other side, I have two hydrogens. So those groups are the same, so again, this is neither. So the next slide just shows you those answers. So here's a few more examples now using line angle structures. These I also want you to try naming because it's always good practice, and then it'll help. I'll show you where the cis and trans goes in the name. So first example, we'll draw the line through the double bond. We know there's hydrogens missing here based on our bond count to carbon. They each only had 3 bonds, so there's hydrogen missing. So carbon on the left has a hydrogen and a carbon group. One on the right has a hydrogen and a carbon group. So the hydrogens are on opposite sides, the carbon groups are on opposite sides. We call this trans. So then to name it, just like before, we need to give the double bond the lowest number possible. Which is going to come by numbering from the left. Puts the double bond on number 2. We've got a methyl group on 4 and 5. So we've got 4,5 dimethyl. We've got trans. 2, 6 carbons is hex, and then E and E for the double bond. So it's the same numbering or same naming rules as before, but now we have to include cis or trans in the name. Usually it's put before the number of the name, or number of the double bond location. Next example, we again draw a line. We know we're missing hydrogens. Those hydrogens are on opposite sides. Carbons are on opposite sides. So again, it's trans. If I number from the left, I'll give the double bond number 3. From the right, it would be number 4. So I'm going to go from the left. We've got an ethyl group on number 5 and a methyl group on number 2. So we're going to list the ethyl first. So 5 ethyl, 2 methyl. We've got trans. Double bond starts on 3. 7 carbon chain is hept. Double bond ene. So 5 ethyl, 2 methyl, trans, 3 heptene. Go ahead and pause the video and see if you can do the second 2 examples on your own. All right, first example on the left. If we look at the carbon on the left of the double bond, it has carbon chain on both sides of it. The one on the right has carbon chain on one, hydrogen on the other. So with this one, it does have 2 carbon groups, but the 2 carbon groups are different. So this is a little unique to this textbook, but this is how the homework is going to have you answer questions and how I will expect you to answer them on a quiz or an exam as well. So a lot of times we would say because there's 2 carbon groups, it's neither, but the carbon groups are different. So in this case, we are going to be able to do cis and trans, and it's going to be based on the longest chain. So if I go through and number my chain, like I would for naming, what I'm going to notice here is that my longest chain is on opposite sides of that double bond line. I've got part of it goes towards the top, the other part of it goes towards the bottom. So we are going to call this trans. So for groups, we've got a methyl on 2, a methyl on 4, 2 of them on 6, and 1 of them on 7. So we've got 2, 4, 6, 6, 7. That's 5 groups, so it's penta. The group is methyl. It is trans. Double bond starts on number 3. 8 carbons is oct. Double bond is ene. So again, these type of problems where you've got 2 carbon groups on the same carbon of the double bond, but those 2 carbon groups are different. This textbook does do cis or trans based on how the longest chain goes through that double bond, whereas a lot of other videos and examples might not use cis or trans there. So be careful. All right, this example on the bottom right, here's our double bond. Both carbons have a hydrogen and both carbons have a carbon group. So we do have cis or trans. Things are on opposite sides, so this is also trans. Numbering, if I number from the left, double bond is on 4. If I number from the right, double bond is also on 4. So I have to look for, the next tiebreaker would be giving the groups the lowest number possible. Red gives groups on 6 and 3. Blue also gives groups on 6 and 3. So numbering groups doesn't break the tie. Next thing to look at is alphabetizing the groups. So in this case, we've got an ethyl group and a methyl group. So the E comes before M. So that means I want to give the ethyl group the smallest number possible, which is the red numbers. So I'm going to use my red numbering system. So we're going to have 3 ethyl, 6 methyl. It is trans. Double bond is on 4, using my red numbers. 8 carbons is oct, ene, because there's a double bond. Here's a few more examples. Go ahead and pause, try these on your own, and come back and check your answers. All right, running through these real quick. We've got carbon groups on opposite sides of the double bond. It's going to be trans. Double bond, I'm going to number from the left to give it the lowest number possible. So that's number 3. 8 carbons is oct. E and E for the double bonds. Now I need to look at my groups. I've got a propyl group and 2 methyl groups. So M comes before P. So I've got 2,6-dimethyl, 5 propyl, and then the trans 3-octene. Next example again is trans. This time I'm going to number from the left. I've got a methyl group on 2, ethyl group on 5. So I've got 5-ethyl, 2-methyl, trans, 3, 7 is hept, E and E for the double bond. Last example, my carbon groups are on the same side this time, so this is going to be cis. If I number, I'll give the double bond number 2. I've got 2 methyl groups on 4, a methyl group on 6, and a methyl group on 8. Be careful not to make this first carbon a methyl. It's actually the first carbon of the chain. So we're going to have 4, 4, 6, 8 tetramethyl. We do have cis. It's on number 2. 9 carbons is not non, and then E and E for the alkene. So 4, 4, 6, 8 tetramethyl cis 2 non-ene. So that's cis and trans isomerism and how you include it in the name. Those two are going to take some practice, so make sure you work through some extra examples. The next video will talk about physical properties for alkenes and cycloalkenes.